All right, so today we're going to review the key elements of a heating curve. And the first thing we're going to do is to make a copy of this template of a heating curve. We learned yesterday that the heating curve provides us with 5 segments, 1, 2, 3, 4, 5. And today's template has points A, B, C, D, E, and F. So the first thing we're going to do on this heating curve is we're going to give it a title. And we're going to call this the heating curve of water. And each particular element, substance, has its own heating curve based upon the boiling points and the freezing points. So the first thing I want to do is talk about the actual phases or the states of matter. The first is solid. So the first phase is a solid, and it's at the lower end of the temperature spectrum. The next phase is a liquid. In the middle, a diagonal line, another diagonal line, and the third phase is a gas. So the 3 phases are on the 3 diagonal lines. We know that as we go over with time, that the temperature is increasing. So I'm going to write temperature increasing. This temperature is also increasing, as well as this temperature increasing. So as we move over time, we see that the temperature increases from a solid towards a phase change. A liquid is increasing in temperature towards a phase change, and a gas. Now we know when we add thermal energy, we know when the temperature goes up, the molecular motion goes up, and when motion goes up, kinetic energy also goes up. So every time the temperature goes up, the kinetic energy goes up. So these phases, solid, liquid to gas, the temperature is increasing every time, and the kinetic energy is also increasing every time. Now let's look at the phase changes. These horizontal lines, these lines here, these plateaus, these flat lines, these are phase changes. This is melting, and this is vaporization. Melting from solid to liquid, vaporization from liquid to gas. Now, there's something I'm going to write on the bottom to help you remember where different energies are going to be. It's called 3 P's. So the first one is a plateau. A plateau is the flat line. These are flat lines. These are the plateaus, one of the 3 P's. The second P is a phase change. And you're going from one phase to another. So from one phase to another. For example, solid to liquid, liquid to gas. So on these plateaus, flat lines, you have phase changes. And the last P is potential energy, no motion. So here in these green areas, we have flat line plateaus where phases are changing and the potential energy exists. The temperature isn't rising, there is no rise in kinetic energy, and there's no motion. So the potential energy increases as we get to the next phase. Kinetic is movement, temperature, and then we have no movement, potential. Kinetic to potential, kinetic to potential, kinetic to potential. Okay? The next thing I want to add to this graphic organizer is where we have a mix. Right here is a mix of solid and liquid. In this area, and when we melted ice cubes as our lab, we saw that there was solid and liquid together at the same time. That's the melting phase, the change from solid to liquid. Right here is another mix. Liquid and gas. So in this area here, this plateau, this potential energy is changing the liquid to the gas. And the last thing I want to point out is about temperature. This area here is 0 degrees. That is the melting point. From here to here, from B to C, is a 0 temperature with no change. It is a constant temperature. We have another constant temperature from here to here. From D to E is another constant temperature, 100 degrees Celsius, and that is the boiling point or the point of vaporization, and that is another constant temperature. So these flat lines, these plateaus, these phase changes have constant temperature. The temperature is not increasing. It's increasing with kinetic energy up as a phase, and then it stays the same until the energy changes back to kinetic. It stays the same at 100 until we get back to kinetic. So this is everything you need to know about phase changes, about increasing temperatures and increasing kinetic energy, and where potential energy is located. Hope you enjoyed it.